Hello everyone, welcome to the IEEE-PES-DSCE YouTube channel. This is the EGen podcast with your host Lortan.
I'm Shreyas Sanchan. We'll be talking about the origin of electricity. When we talk about the origin of electricity, the first thing that comes to my mind would be lightning. Lightning was always been a huge question mark for human or mankind because no one knew what it was. It was just people used to think it's a god's wrath and just strikes down on the earth's surface and then everything turns to dust. But then there were people who would question that, like why something like that would exist in the nature and what is it? Because lightning back then wouldn't serve much purpose for its existence. So people always ask this question. Also, when you go to the Greek history, there was this instant where people would rub the glass rods and use the glass rod and attract the feathers. With all these instances, we can talk that it was the initial sparks for whatever the question arised in the human mind.
Now we move into, let's say, excuse me, the 18th century or the 1700s, where the first instances of trying to understand electricity was from a person known as Francis Hawksby, who was the head of demonstrations under the Royal Society during Isaac Newton's leadership of the Royal Society. So, as the head of demonstrations, he would make many experiments. One such experiment, it was later termed as the Hawksby machine. Can you show the Hawksby machine? So, Hawksby machine consisted of a rotating glass sphere, evacuated glass sphere, which was evacuated using the newly discovered air pump.
Yeah.
So when it was rotated with a crankshaft, a person would keep their palm on it, and they would notice a blue light tracing the palm. So we might consider this as the first instance of artificial electric phenomenon.
Yeah.
It was also the first electromechanical machine ever produced.
Yeah, you are right. It was actually the very first electromechanical machine, and also the blue light which was viewed was the electric charges which people viewed, and that was the first time when a human saw electricity so close. It was usually the thunder which they see, but here they actually saw the light being traced or the electricity being traced by hand. How that actually works is basically when you rotate the crankshaft and the glass rod just rubs through the palm. When you rub through the palm, the static electricity is generated within the glass. Because of that, the charges which move around emits blue light. And further on, when we go, there were some more questions which was introduced, like we can produce something like that, static electricity. Can we store that? So that question was actually answered by Mushenbrook's accident. This was actually a really funny incident in his hand, or a funny mistake which he did. The actual experiment goes like this. You make a Leyden jar. Leyden jar is basically a glass jar filled with water, and there is a wire which is dipped inside the water, and there is a insulated rubber or any insulated cork, and there would also be a metal ball on top of the cork, and that would be connected to the wire, and then the other end of the metal ball is connected to your machine, a Hawksby machine here. For when you actually produce the electricity from the Hawksby machine, that is in turn going into the Leyden jar, which is producing charges. So when you keep it on an insulated plate, there is a sort of insulated boundary created within the jar, so that all the charges gets trapped in. That is the reason why Mushenbrook couldn't see any electric charges back then.
So the accident basically was during one of these experiments. When using the Hawksby machine, actually, he held the Leyden jar on his hand. So after rotating it for a long time, he touched the metal ball on top of the Leyden jar, and in his own words, felt a pain felt a pain so powerful that he wouldn't want to repeat this experiment ever.
Yeah.
What he got was a very you know he got the first electric shock, I guess.
Yeah, that was. I wouldn't say it was the first electric shock, but it was the first electric shock within a room. I wouldn't be wrong when I say that. But he also stated one thing in his journal that it shouldn't be done in a in an unsupervised manner, because what shock he got, he was just thrown across the room, and that was a really painful thing for him. He basically gave us the instruction in this journal that we usually give it in the TV, saying kids don't use this or kids don't try this at home.
So kids don't try this at home.
Kids don't try Leyden jar experiment at home. Later, when you talk about Leyden jar, what basically it worked as was simple capacitor, which we usually see
It
everywhere.
can be equated to the modern day capacitors.
Yeah, it's basically the capacitor, because when you hold the Leyden jar in your hand, the hand will be producing a sort of positive charges
No,
from
actually
the ground.
it's something like it will store charges. So because of that, you can equate it to a modern day capacitor.
Yeah, you are right.
Because even during the invention of the Leyden jar, no one knew the concept of positives or negatives.
Yeah.
That was explained by Benjamin Franklin, I guess.
Yeah, it was Benjamin Franklin's accountant's ideas, or accountant's beliefs, I might say, which gave the idea of positive and negative. What he meant was, by these positive and negative terminals, or positivity and negativity in electric charges, is negativity is something, the credit which goes out, and positivity is something that comes in, or the debit. This sort of idea explained the mistake of Leyden jar experiment by the Muschenbroek. Basically, what happened was, when you produce the electricity, or use the Hawksby machine to produce the charges into the jar, there is a negative charges going into the jar. While when you are holding it, your body is touching the ground. So from the ground, you're getting a positive charges attracted to the surface to your hand, and there is a insulating material, which is your glass, in between. Since there is an insulating material, the negative can't come here and the positive charges can't go there. They're just stuck. Also, he also mentioned that positive charges and negative charges has to be equal, like an ideal American economy.
That's Benjamin Franklin for you. I
Yeah.
guess. Also, we always, whenever we think of Benjamin Franklin, we always equate him, we think him with that famous experiment, which that famous experiment picture of him flying a kite with his assistant on a stormy day, trying to capture lightning into a bottle. He proposed it. He never did one of these experiments. He's like that friend who's, he'll give you ideas, a lot of project ideas, but he'll never do any of those.
He's
So
just-
be careful of such of these friends. Okay, be careful from them. Be careful of them.
He's that lazy friend we have in our group who doesn't do anything.
Yeah.
So further on, when we talk about electricity, I would go to Luigi Galvani and Lisandro Volta's rivalry. That starts.
Also, before we get into the rivalry, we have to talk about Henry Cavendish.
Yeah.
So what Henry Cavendish basically did was, he was part of the Royal Society of London. So during his research, he came across this fish known as a torpedo fish, which we today know as the electric ray. So what happened was, these electric rays would give mild electric shocks to people whenever they would come near and touch it or feel it or anything like that. So Cavendish wanted to understand how it worked. So he basically devised an experiment where he kept a Leyden jar buried under sand with a extension with a very long glass tube connected to the Leyden jar, which had a metal ball connected to the Leyden jar itself. So when the jar was charged and when he kept it inside this environment, when he touched the metallic ball tip, he would feel a mild electric shock. So he had found out that even animals were able to produce this electricity. So Galvani was the first person to call this term as bioelectricity or animal electricity.
Yeah. So basically, the problem happened was the Cavendish experiment here produced the torpedo fish here would produce a low voltage, high charge current. Because of that, you get a current shock, but the intensity of that is very less. In the case of the Leyden jar, it's the opposite. It would produce a high voltage and low current, a low charge current. Because of that, the intensity of the current shock you get will be more, so that you'll be thrown out. That is one of the reason why Motionbrook was thrown away from the Leyden jar. But the same thing was questioned by Galvani, because we back then people didn't know the ideas of voltage, current, or charges. They knew nothing. All these things were just observed. So Luigi Galvani just asked this question: if they are different, how if they work as different, if the intensities are different, how are they same?
So what he did was he took Leyden jars, or he would connect a copper wire to a Hawksbee machine, and when he started rotating the Hawksbee machine, he had many, like, he was basically a anatomist, so he had many dissected frogs lying around. He would just place the copper wire on a muscle fiber or any nerve of the frog, and when the Hawksbee machine was rotating, he would notice that the legs would twitch as if the frog was still alive.
Yeah.
So then he thought that maybe the electricity produced in animals is much different. Maybe they might have special organs that can produce this animal electricity, which he wrote a book on, which has a complicated Italian name, which we won't try to pronounce.
It's a really hard name. Goes by animal electric.
Don't, we won't even get
Yeah,
into pronouncing.
please don't quote us on the pronunciation here. But that all those theories of what Luigi Galvani stated of animal electricity was totally disapproved by Alessandro Volta. He stayed in a small town which was one Volta. He stayed in a small town which was 150 miles away from Bologna. Bologna is the place where Galvani stayed. Even though they're just 150 miles away, their thinking process were far apart. In the place of Bologna, people were really conservative. They used to think of the God's wrath or act of God and
The
take it
church, I
seriously.
guess you can say that.
They were the followers
church,
of the church, yeah.
No, not just the church. The church still had a powerful hold on the
Yeah,
people.
exactly. But in the place where Volta stayed, it was a place filled with liberals. They were all questioning, reasoning everything around them. So out of them, Volta was one such guy who was totally skeptical of the idea of animal electricity. He was like, electricity should be the same. How are they different? So he produced one more. He started questioning it.
Also, I'll add a point to that. Volta also noticed that whenever he took different metals like copper and zinc, and when he placed it on his tongue, he'd feel a certain metallic taste,
Yeah.
which we now can say it's due to electrons flowing through the
Yeah, exactly.
like sensory nerves, all that stuff of the tongue, something like that. But he didn't. So he thought this was some kind of electric phenomena. So what he did was he took two circular plates
plates.
of metal plates of zinc and copper. Between them, he would sandwich acid-soaked paper, and one of this like set. He would repeat it again and again like a pattern. So it would be metal, acid, metal, acid,
metal,
acid.
also.
So after like creating a huge pile of these, he connected two copper wires at each end, and he placed it on his tongue, and he felt the same phenomena that he would get from placing different metals on his tongue. What he didn't know was he had invented the first battery ever.
Exactly. It was like the first battery of mankind had ever seen. You can actually perform this particular experiment at home. Basically, take some coin or something and just place it on your tongue. You would find some peculiar taste. That it should be clean coin. Just don't take some random dirty coin and taste it and say there's no taste.
Also,
that would be
remember,
the
our
battery.
elders would check whether the battery was still functional. They'd place it on
Yeah.
that 9-volt battery.
You would still get some metallic taste. That metallic taste is basically the taste of electricity or the flow of electrons. That is one instance of flow of electricity which we consider. And one more thing I have to add on to this here was the way the electricity started flowing from the pile was similar to the way water used to flow or still flowing. So this the way water flowing, we call it as current. The same way we started calling the flow of electricity as
Electric
current.
charges. Flow of
Flow of electric charges as electric current. With this, we have we
Also,
can see a huge
due,
milestone.
due to his significant invention, the pile was named after him. It was called the voltaic pile, which
Yeah.
was one of the first batteries ever. And also, one of the major units for measuring potential or potential difference is volt, which is named after Alessandro Volta.
One more thing we have to appreciate in them is all these things which they did. They did it out of pure observation.
And curiosity.
Yeah, curiosity.
To find out more.
They didn't do anything without knowing the fact that what potential difference is. Because to make a pile, you need to know the potential difference. To be honest,
Yeah.
you need the distance between the plates, the distance, the length of the plates, everything. They all carry on to the potential difference. Without that, they made a pile. They produced electricity. That was the first ever constant electricity which they produced. Until then, with the Hawksby machine, you would produce electricity, but it was for a small instant. You would get electricity and then there is boom, no electricity. And then you have to still rotate it again and then you get it. But here, you get it constantly until all the acid gets over. So this is the same way how the modern day batteries are still there. You put distilled water inside the batteries. That's basically a weak acid which is there in pile. After this, we would see Humphrey Davy, who
Yeah, Humphrey Davy's famous experiment. So, during the Royal Society used to have these weekly demonstrations open to the general public. So, during one of these demonstrations, what he had done was in the Royal Society's basement, he had created one of the largest batteries ever
Yeah.
using multiple voltaic piles. He laid them across it was said to be 4 meters wide, and its dimensions were actually 8 into 4 meters. So it was really large.
yeah, and then he connected the two ends of the
Yeah, it was
pile
connected to two carbon rods, and when he just touched them with each other, a really bright spark was emitted.
Yeah, that was the first ever light created by mankind. Other
Which
than
was
fire,
fire.
other than fire, using electricity, it was the first one. I would say it was the second one. Still, fire was still created by the static electricity or the spark between two rocks.
Yeah, it was just like a bright spark. Let's just
Yeah, we'll just keep it at that. But yeah, this spark, I would say that there was not only one spark which was being ignited there.
Indeed. What we also forget is, what many people don't know is, during many of these demonstrations of Humphrey Davy, there was in the audience member, there was another bright spark.
Yeah.
He had attended that demonstration because his friend had bought a ticket but couldn't attend it, so he gave it to him. And he was dazzled by all these scientific demonstrations. His name was Michael Faraday.
Exactly. With this particular experiment, I would say is a huge milestone in the history of electricity, because this gave rise to the new subject which we know as electrochemistry. Basically, what they did was, after this arc light or the Davy's lamp, they used the same two electrodes and put it in water to see what happens. When they put it in water, they saw that water being split into its constituents, hydrogen and oxygen. That's basically the electrolysis which we know. With that, electrolysis was born. And also, we have to appreciate Humphrey Davy. He was not only in this Davy's lamp, but he was like the one who showed how we can store calcium, strontium, boron, and other elements in electricity. Also, he was the one who experimented on laughing gas, nitrous oxide, and he was actually the one who named the gas laughing gas because of its
Its
property.
effects
Yeah.
on the human this thing.
On
So
that,
on the let's before like concluding it, let's look at the time frame. What 150 years, man went from let's say calling lightning as an act of God or the act of a higher cause to be able to replicate it.
storing it, storing it,
And storing this
storing it,
this
and
form of energy, I guess. Yeah.
using it for other applications. We have come a long way within a short span of time, because all these things had to come across the church back in the days, because people were back then people were pretty strict when it comes to the language of God. I mean, stuff with gods. They were really orthodox and really strict. So, but then it was really, we have to appreciate their bravery, I have to say, because back then, even in Newton's theories, we would see the act of God being not questioned. He would just say, "This is how God wants it to be, and
Will
this
not
is how it
question
is."
it,
Yeah,
I
this is
guess.
how it is. But it was after a long time, after this much of time, we were able to come out of that, and still there was resistance, but the time with time it reduced, and people started questioning things.
So before we end this podcast, like we talked about Michael Faraday, right? Even he got significant, you know, he shed light across significant effects of electric phenomena, which we can't get into this video because it will be too long. It's already 22 minutes on the clock, I guess.
Yeah.
So with that, we bring an end to this video. Uh, Please follow us on all our social handles, which will be provided in the description of this video. Like, share, and
Subscribe. Thank you.